And I have to mute myself on the stream so that I don't get redundancy. All right. Let's I'm gonna launch Revit here. A reminder, we are using Revit 2021. The data sets posted are in this version. Most of you are using Revit LT, and it should work. The data set will work fine. So for this exercise, I would expect you to follow along with me in the exercise. We all going to move at the same pace in the development of this tutorial. Please, I try to slow down when I see that the sequence of command is a little complex, or I try to repeat it a couple of times in case anybody falls behind. But if you want me to repeat, please don't hesitate to ping me on the chat panel or raise your hand, or I'm happy to step back a couple of instructions so that you don't fall behind. And again, Revit it's a piece of tool that you can only learn by doing, and that's why these classes are hands-on. And my goal here is to teach you by doing or executing. There's little point in me just showing you how the tools work without you getting immersed in the reason and the logic behind the operations. Okay, so last class I show you an outline that disclose all the different steps required for creating a fully parametric family. And I place a copy of my slide deck in the Google Drive if you want to download it. It's in PDF. And I'm going to use this footprint as a reference for developing the cabinet family that we're going to create. And so the family that we're going to create is it's a shelf family. We're going to create 4 different nested families that are going to be assembled into a container family. And we're going to start from the very basic. We're going to start with let me pull the end results. This is a wall bay cabinet. And this cabinet has the ability to be associated with the different type of materials. It has a parametric shelf, it has a nested door, and it has a nested pool. And so in a nutshell, what we're going to do in the sequence of workflows is first we're going to create the pool family. And in here I'm going to show you how we can use sweeps as a modeling tool and assign materials. Then we're going to create one of the doors, a door leaf. And we're going to study here how we create extrusions. How can we offset extrusions by work planes? And how can we nest a family inside another one? In this example, we're going to nest the pool family inside the door leaf. And then we're going to create the shelf, a single shelf. The shelf is going to have dimensional parameters in X, Y, and Z. And finally, we're going to assemble all those three components into a cabinet family, and hopefully these highlight you the process of creating a family using different subcomponents. Any question on the process? All right, so we will get started now. I'm going to repeat the latter part of our last class. So in the Revit interface, you're going to see the family editor sitting right below where it says the model ones. And you're also going to see a big section called families, which display the thumbnails of the last set of families that you created. A lot of you have not experienced creating families from scratch. And then you're going to have, I think, 4 placeholders, which are the default out of the box. Let's get started in the process. So using this as a footprint, we're going to define the family category and check the reference planes. Reference planes are working two-dimensional work planes in space that allow us to define the framework of a family. And think of this as the skeleton of a family, and solid geometry is controlled by this framework. It's just like, you have your arm and your mass, and so the skeleton is moving the mass. So that's the purpose of a work plane or a reference plane. So we're going to start a new family using the new command, new family. Do not start the model. We're going to start a new family. And whether you're using full Revit or LT, it's always going to display the English Imperial, and it's going to display all these different templates. Templates have the extension RFT. It stands for Revit Family Template. And this is a selection of family categories available out of the box. This does not represent all the families possible, all the categories in Revit, but I'm going to show you how we can get started with one family type and change it later. And so that you know what we're going to do, you see this screenshot here. That's what we're going to do. We're going to create a new pool, and this pool is going to be parametric. So for the pool, I'm going to start with a template called generic model. That's it, generic model. There are all these different types, but you just pick the one that says generic model and then hit open. The family editor, for those who are new to the user interface, will display a solid editor. And these are different ways of creating geometry representations. All of these ways of creating solids are based on a profile and a path. The profile is something that you build using sketch lines. And if you remember, if you've done floors in the past, you probably edited the profile of walls in the past. And sketch lines are the boundaries of solid geometry and that are created using sketch lines. And to properly create a profile, the sketch lines needs to be in a closed loop, and they don't need to overlap, right? And so you can create solid forms. You can also create void forms. Void forms cut by default a solid form, and then the combination of solids and voids, you can basically create anything, any representation of anything in the family space. All right, the other thing I said is that inside the family templates, there are default templates or default work planes. These work planes are system work planes that comes with a template. And if you notice, when you select these work planes, they cannot be deleted. This is the delete command because the default work planes that are associated with family are system references, and you cannot remove it or change them. The other thing that you need to pay attention is that there are work planes that defines the origin, and usually the intersection of a horizontal work plane or reference plane and a vertical one that has an origin checkbox to define what the insertion point is going to be. And so this work plane defines an origin. The name of this work plane is called center. This horizontal work plane is called front back because it splits the space between the front and the back, and it also defines the origin. You can choose where the origin lies, but in the case of this spool, this is the first exercise, we're going to leave the center of the pool as the insertion point. So work planes are planes. If you look at the project browser, you can switch to different views. Let's say you can hit the 3D view, the default 3D view, the little house in the upper left side. And notice that the work planes sort of disappears. The work planes are only visible in projection views. So if you open like the floor plan or the elevations front, then you're gonna see your work planes in projection, but they are not gonna be visible in 3D. That's a default behavior. So when building families, for the most part, we're going to use projection views. So I like to stack my views in quadrants when I'm creating families, because then I can very easily switch between plan, front, elevation. And so I'm going to tile the views. And to tile the views, you remember the shortcut. If you type on the fly WT, there's window tile. And that shortcut is going to tile all your views in the view space. Now I have views that I'm not going to use, like this view 1, I'm going to close it. Then I'm not going to use the 3D for now. And then I'm just going to, again, zoom all, or if you click in the zoom controls and you click this zoom all to fit, I don't know if you were familiar with this, but when you hit zoom all to fit, all the viewports that are tile are going to extend to maximum. Zoom all, and notice how all the tile views zoom to the full extent. So I have a front view, a plan view, a left view, and the order in which they are organized doesn't matter that much, as long as you have these 3 views in the view space. That's what matters. So any question here? Following along? All right, so let's see where we are in this process. Trying to move my cursor to my second screen, but doesn't look like it's letting me do it. It's weird. Okay, here it is. So we defined the family category. there are reference planes already in the template, but we're going to add additional reference planes. And so in the reference floor plan, which is the one I have here on the right side, I'm going to create 2 additional reference plane. So give me a second. So all right, so I'm going to create a reference plane right here and another one right here. I'm going to call this the front reference plane, and this is going to be the back reference plane. And this is going to define the vertical boundaries of the pool. So the reference planes are under the Create tab. Hit the reference plan. Not confuse the reference line. We want a reference plane. The shortcut of the command is also RP. You can just type it on the fly. And I'm going to create a reference plane below, in front of the center one, and another one above. When you're done, just hit escape. Notice how these reference plane automatically transfer to the elevation views. And this is going to be the insertion point of the family, and the pool is going to be created in this direction. And so I want the pool to grow parametrically using the insertion point, and I need to make sure that the distance between the reference planes and the origin, the horizontal origin, is equal. And so I need to place a dimension that equalize these distances. So I'm going to create a dimension, a line dimension, and hit the front reference plane, the center one, the back one, place it. Your values are going to be different than mine. That's fine. But just hit the EQ icon to equalize the distances, the location of these reference planes. So, and as you know, I mean, you're familiar with Revit, the equalizer allow me to change one dimension, and it will automatically move the opposite one. All good here. So we are now here on the third step, add dimensions. And then these dimensions eventually are going to turn into parameters. And so in the front elevation, or you can even do it in the front elevation, I'm going to create another reference plane, and this is going to indicate the height of the pool. So you just type RP on the fly. RP equals, that's the shortcut of reference plane. And you can just type it on the fly. So create a reference plane, and just create another one on top of the bottom reference level. And I'm going to place a dimension. This dimension represents the height. Again, I'm placing this in the front elevation of the family. All right, I also need a dimension that's going to represent the pool width. And so I'm going to create another align dimension at the floor plan, at the reference level, from here to here. I'm going to place it. All right, so my pool is going to be constrained, or is going to be flexed by 2 behaviors. This is going to drive the width of the pool, and this one is going to drive the height of the pool. And so transforming a dimension into a parameter is the next step in the process. We're going to create dimensional constraints or dimensional parameters. And the easy way to convert a dimension into a parameter is to select it, select the dimension, and then look at this little icon that looks like a calculator with a little star in the upper right side. This is going to create a new parameter. And when you create parameters, you need to define information about that parameter. What is the name, whether it's going to be a type or an instance, and where the label is going to appear in the Windows property. So you recall the difference between type and instance, right? A type parameter, it's a parameter that is common across all the elements of the same type. If you change a type parameter, you change it for all the elements. And then an instance parameter is a parameter that is unique to an object. And for this particular example, I'm going to make it a type. So I'm going to call this pool underscore width. And I'm going to place on the dimensions and then hit OK. So when you say group parameter under dimensions, that means this parameter is going to be accessible under a parameter group. The parameter groups are disclosed to you under this icon, and we're going to be using this a lot. This is the family types. And the family types disclose the data contained by a family. When you hit this family has some identity data parameters. These are brought in by the template, but it's also disclosing the new parameter that I created, the pool width. And remember that dimension group, that is what telling Revit where this parameter is going to be placed under this family dialog box. And do you have like 20 different options of parameter groups? And you can organize it as needed. I mean, I pick dimensions because it's more logical. I mean, these are dimensional constraints, but there are others like energy, materials. There's another one, electrical, etc. All right. So that's family types. I'm going to add another parameter in the front elevation, which is going to represent the height of the pool. So you select the dimension, and then again, I'm going to create a new parameter. So you click on this icon that's like a calculator with a little star, and I'm going to create a parameter called pool height, pool underscore height. And it's going to be a type parameter. And I'm going to hit OK here. And I decided that my pool is only going to be driven by these two factors, by these two parameters. Things like the pool thickness or the pool diameter are additional parameters that you can choose to use. For the sake of time, I'm just going to keep it like this. All right, and then I need to give the parameter something that is relatively reasonable. I mean, this is a 2'8" and this is 1'6". So I'm going to open again the family types in the upper left side, and I'm going to give it a placeholder dimension. So the pool height is going to be 1.5 inches, and the pool width is going to be 6 inches. And make sure if you type inches, make sure you add the inch character. All right, and this is like a reasonable pool size. And again, what I'm doing right now is to define, I add the dimensions, and then I create dimensional constraints, dimensional labels that translate into parameters that are going to derive the parametric properties of the geometry. Okay, let's see. Another key concept in creation family is flexing a family, and what I showed you last time. Flexing a family is the process of testing different parameter values. So flex a family, it's test different parameter values. And when you flex a family, you're just visually doing quality control to make sure that the family is behaving according to your plan. And so I'm just going to quickly test the pool width. If I change this to 4 inches, then notice how this dimension changes. I change this to 5, and it does change the properties of the height and on the width, and on the height. If I change this to 2 inches, then you can also see that the parameters are changing. So I'm going to go back and leave those at 1.5 inches and 6 inches by default. So that is flexing the family. So the next set of instructions is to create a symbolic line work. And symbolic line work, it's a symbolic representation of the element. Let's just add one symbolic line. And what that means is that when I switch in Revit, remember that we can display objects in different resolution. So you can have objects in coarse view and fine view. And in the family editor, we have the ability to display certain elements in certain views and disable it in other views. And so for the pool, a very simplified representation of a pool, it's just a single line. If you and coarse views are suitable for very large scale details, so that you don't make the detail or the elevation look too busy. So I'm going to create just one symbolic line that represents the pool. And you're going to do this under the Create tab. And I'm going to create a model line. And the model line is going to snap from the lower intersection of reference planes to the upper intersection of the reference plane. And once you do that, you just hit escape. And let's see if this two-dimensional line flexes. So if you go back to family types and change this to 4 inches, hit apply, and notice that with any change of the parameter value, the line flexes with it. And this is the result of something called hidden constraints. This is probably, you don't need to know this, but when you snap geometry to grid intersection, it creates an automatic relationship with that intersection point. And you don't need to do this. I'm just going to display it. When you do visibility graphics and go to annotation categories, notice that there is one checkbox called automatic sketch dimensions. And when I display it and hit OK, notice that there is the 0 zeros. This is a dimension that is constraining the line work geometry with the reference plane. And this was the result of snapping to the intersection of a grid. So the lesson here, and this is important, is that in the family editor, snapping to references create alignment constraints. So so this is a very basic rule. Try always to snap geometry to reference planes, and then you're gonna automatically create those constraints. Now this is on the way, you don't need to know this. So I'm gonna go back to visibility graphic and disable the automatic sketch dimensions, and then those dimensions will be gone. So any question here about symbolic lines? This is a symbolic line. It's a very simplified representation of a pool. All right. The next thing I'm going to do is to, now that I have the framework and the line work, is go to the next step. The next step is to create the 3D solid, which could be a combination of solids and voids, and associated with the reference planes. And so this is, I'm going to do a sweep. And let me quickly show you what a sweep look like. A sweep, it's you can see it right here. It's a profile that is extruded perpendicular along a path. You can choose what path you want the extrusion to travel. You can also develop what is the extrusion profile. And so when you create an extrusion, you're going to start by defining the path. So that's step number one. You know, where is the extrusion, where is the profile going to travel? And then step number two is to create the profile itself. And the profile is going to be hosted in a work plane that is perpendicular to the path. And this is a multi-step operations. So I'm going to do it twice. If you want to just look the first time, that's fine. I'm going to repeat it again. All right. So the first step is to define the path, and the best way to define the path is in the left view, or the left or the right view. The path of an extrusion is going to look like this. And then after I define the path, I'm going to define the profile. The profile is going to be a circle. The circle is going to be hosted on a work plane perpendicular to the path. And then the circle is going to get extruded along this path, and it's going to generate the pool shape. All right, let's do it. So you go into the Create tab, and then you hit, I'm going to repeat this twice. And then you hit the sweep command. The first step is to sketch the path. So I'm going to make my left view the active view, and then I'm going to sketch the path. And I'm going to, again, snap to the intersection. And to force the snap to the intersection, you can just type on the fly SI, and then go to SI. And look at right when I'm in the middle of creating a sweep, you see that green line. That is actually the work plane that is going to host the profile. So I'm going to get back to that work plane later. So that's my first point, and then I snap to the intersection, and then I continue, make sure that there's this chain checkbox is enabled to create a continuous loop. And then I'm going to create my other one, and then I'm going to close it here, escape. That is the path of the sweep. And then I finish the path of the sweep. So you have to click this green checkbox. And don't worry, I'm going to repeat this again. And then the next step is to create the profile. And the best view to create a profile, it's in the floor plan. This is the work. You see that X, that is my little work plane that is hosting the sketch line of the profile. So I'm going to click Edit a Profile to create the profile. And then I'm going to create a little circle, snap to the intersection of the work plane, SI, and then make a pool that it's 1/4 of an inch. And escape. And then I click again the green checkbox to finish the profile. And then the next step is to click the green checkbox to finish the sweep. So you're gonna hit this checkbox 3 times. The first time is to finish the sketch. The second time is to finish the profile. And the third time is to finish the sweep. And that is the pool. When you look at this in 3D, that is how it looks like. So I'm going to undo this and do it again in case you fall behind. Let's do this together. And if you have questions, just raise your hand or let me know in the chat panel. All right, so I started the sweep in the floor plan, in the reference level. No, my bad. I started in the left view because that's the path. And so you go into the Create tab, and then you hit the sweep command. Then you're going to hit Sketch a path. The path is going to be hosted by the work plane you draw, and I'm going to draw on the left side. So you sketch the path, and using the draw tools, I'm going to trace the path of the profile. So I'm going to force snap using SI, and then make sure you snaps to the intersection of work planes. And those dash lines is a representation of, it's a pre-selection of reference planes. And then I continue snapping to reference plane. To finalize, I'm just going to type SI again, because I want to make sure that I snap to reference intersections, not to the line work. And that is the path. Once you finish the path, you hit the green checkbox to finish the path. I'm still in the middle of the command, and now it's time to create the profile. And the profile, I'm going to draw it on the top view. So you hit Edit Profile. I need to activate my reference level. And then I hit the circle. Draw a circle at the end point. Make it the radius 1/4 of an inch. You can do other type of, if you want to do this a cube or another shape, you feel free to do so as well. Circle is easier. Then finish the profile. That's the second green checkbox. And now if I'm happy with the path and I'm happy with the profile, then I hit finish the solid, and that should generate you the pool. So switch this to shaded. That's how the pool look like in 3D. That makes sense? Okay, any question? Did you guys got it? If you give me a thumbs up, just make sure that it's okay. Awesome. All right, so this is the pool, and then the pool is driven by the reference planes. So let's go back to the sequence of steps. So we created the symbolic line work. We added the 3D solid. We can add additional parameters. Parameters, yes?
I'm sorry, I have a question. I keep trying to do what you said, and it keeps giving me an error message that I can't have 2 curves when I try to finish putting in the path.
You can you read the message, or is it on your screen? The error message?
It says more than 1 curve not allowed. I have 2 little red points. I don't understand why I have 2.
Yeah, this is what may be happening. I'm gonna edit the sketch. Okay, so there are 2 rules in sketch mode that you need to meet. lines cannot overlap on top of each other. So for example, if I have two overlapping lines, you might get this warning. If that is the warning you're getting, then make sure you delete all these purple lines and start again. Make sure you have only 3 segments of a line, and make sure you are drawing them in the left view. Want to try it?
Yeah, I can. That's not the warning I'm getting though.
It's hard to troubleshoot without seeing your file. So why don't we do this? At the end of the class, let's bring this file, and you can just grab from the Google Drive the pool that I just created, and let's troubleshoot after the class. How about that?
All right.
So for now, Anne, just go and grab the pool that's already created in the Google Drive. If you go to the data set under some fall families cabinet, just grab this pool family and you can copy onto your desktop. And then after class, let's look what happened. Anybody have troubles or similar troubles? Okay. So the next step is to create additional parameters. What other parameters do I need here? Material, for example, I want to make sure that the user has the ability to assign a material of his choice for the pool. And I'm going to do that using there are different ways of doing this. You can create a parameter on the fly by selecting a solid. So this is the way it works. Select the solid, and it's going to display the instance parameters. In the instance parameter, there is a parameter called material, and it says by category. By category means that the family is going to inherit the object style or the global default material associated with the generic models. Generic models, I don't think they have materials assigned. So when you load this solid into the project, it's going to go to the default material. But if I want to control the material of the pool from the project environment, then I have to concatenate the materials. So this little box that is here, it's what you use to associate parameters. And that toggle allow me to populate the parameter value using a custom created parameter. So let's do that. Let's associate parameters. So select the solid. In the material, click the associate family parameter. And here you're going to create a new parameter. And this parameter is going to call pool material, pool underscore material. And because Revit automatically knows it's a material, it automatically assign this new parameter to the material category and automatically is going to place it on the materials and finish group. And it's going to be a type parameter, I think. So I didn't hit OK. So again, this is pool material, and then hit OK. And then hit OK here. And notice how the material parameter is grayed out. It has a sign, an equal sign in the toggle. And this is just letting you know that the value of these is driven by this new parameter. This new parameter is also disclosed to you via the family types. So at the type level, you can assign a material. I don't recommend to add materials in the family environment unless it's necessary, but it's better to do it at a project level. Okay, so I created a new parameter of the material type and concatenated with the solid geometry. So that meets the step number 8, which is create additional parameters. Now, this is an important one. Assign visibility settings to the geometry. And what that means is, where do you want the pool to be visible from? So, and this is, again, this is connected to the purpose of a family. Do you want the pool to be visible in every projection view, elevations, sections, plan? So in technical documentation, and this is my experience, I don't know if this is true in your experience, like pools, it's something that you may not want to see in a floor plan, right? It's just a preference. But the floor plan of this pool, if it's going to be placed vertically, it's the left and the right, right? Like the so you have the ability to control the visibility of the object based on the orientation, view orientation. I'm just going to leave it like that for now. I don't think I need to go to that length of sophistication. But one thing I'm going to do is control the visibility of the symbolic line. So in the reference plan, select the symbolic line, and in the symbolic line, you see this button called visibility settings. These allow me to restrict the visibility of that object in different elevation views. And so I'm going to say that these particular view, this line, it's only visible in elevations if it's not visible in plan. Because in plan is going to appear as a dot, right? And I don't want, actually, let's see, plan view for this view is this view. No, I want it to be visible in plan. No, the only one I'm going to say is that this is only going to be visible in coarse, but on medium and fine is not going to be visible. So I am disabling the line ability to display in medium and fine, and it's going to display it on the coarse. And then for the solid, for the pool itself, I'm also going to change its visibility settings and ask Revit to display this geometry only on fine. So if your view in the project, if your view is set to fine, then it's going to display the pool. But if the view is set to coarse, it's not going to be displayed. And when this is useful, for example, if you have overall room elevations, the pools may trigger very thick lines, and it's going to look it's not going to look good. So maybe in overall elevations, you disable the visibility of the pool, and then at a detail level, like 3/4 of an inch or a half of an inch, you switch the view to fine, and then it's going to be visible in fine.
So
Does that make sense?
you should turn off the single line in fine and only have the 3D.
Correct.
Yeah. Okay. Yeah.
Yeah. So again, the symbolic line, it's only visible in coarse view, and the solid pool is going to be visible in medium and fine. Let's do medium as well, medium and fine. Okay, so that takes care of step number 9, which is assign visibility settings. Now let's flex the family and define types. Remember, a type is a member of a family, and a type it's usually associated with different dimensional sizes. And we can create 3 types. We're going to do a pool that is 3 inches, 4 inches, 6 inches. There are even 8 inches, I believe. And we're going to flex it. So to create new types inside the family environment, open the family types button And right now the type name is grayed out. And what that means, there's only one type. So this icon that looks like a page with a little star in the lower left and upper left, create new family members. So I'm going to create a new family, which is this one. And I'm going to call it pool. I'm just going to pool 6 inches. I'm just going to leave it like that. This is a 6-inch pool. I'm going to create another one, a new type. And this is going to be pool 4 inches. And then I'm going to change the parameter value of the width to 4 inches. You see, when I apply it, then you can see how the pool changes. I'm going to create another one, and this is going to be a pool 8 inches. Pool 8 inches. And then I added a new value, 0.8. Apply it. And now that creates my 8-inch pool. And you can continue creating new types. You can have a family that has 6 different types. I'm going to just stick with 3 types for now. And hit apply, hit OK. And I think my pool is done. It's ready. The last step is to flex it. Flex it is, the last step is to test this in a host environment. I don't have the host yet. So I'm just going to save this file, save as a family. And I'm going to put it into my C drive. And I'm going to call this pool. And then save. We're done creating our first parametric family. Anna, you could just grab the family that's already there. We can troubleshoot after the class. All right. Any question here about the process? We actually run through all of this, different steps for the first family. I guess I think the process is sort of clear. I'm going to do next the door leaf, and I'm going to use exactly a very similar process. So I'm going to close this family. So just go File, Close, and it's going to close the family. Make sure you save it. And let's see what we're going to do. I'm just going to open the Google Drive to show you what we're going to do on the cabinet door. It's very simple. It's we're going to use the casework template. The casework template comes pre-loaded with reference planes. It has 2 dimensions, the height and the width. This is what the door looked like. And then the pool is brought inside. And the pool, it's locked to these reference planes. You see these locks that appear here. Those are alignment constraints that forces the pool to be associated with certain reference planes. And so as we change parameter values, let's say I'm going to change the width of this to 2 feet and the height, I'm going to change it to 3 feet. Notice how the pool reacts to the location of the frame via dimensional constraints. All right, so this is the end result. Let's build it from scratch. So I'm going to close this file and start a new family. So under the families, hit New. And I'm going to go into the English Imperial. And we're going to go into the casework. And I switched to casework because I want all the wood components of the family to be driven by the same category.
Do you want casework or casework wall-based?
No, casework. And then the final assemble, you know, where everything comes together is going to be wall-based. So let's just use the casework one. Hit OK. And notice the difference between this template and the generic model one. The generic model only had 2 work planes. That's how we started. But the caseware template has 1, 2, 3, 4, 5, and then an elevation. I think it has another one. It has 6 work planes, and these work planes were already there. And again, these are system work planes. Notice how you cannot delete them. When you select them, you don't delete them. And the idea of this is that the template provide you a predefined framework of a rectangular box. You have all the work planes of a box, and you can reutilize those for your modeling purposes. And so this is the width, the depth, and I think when you switch to an elevation, notice that there's no height parameter associated there. So that we don't get confused with we don't have misnomers on what the different parameters are. I'm going to make some changes, like the door is going to be crafted in elevation like here, this way. And so this is typically a door height, and this is typically a door width. And so all I'm going to do is swap a parameter. This is not going to be the depth, but this is going to be the height of the door. And you can swap labels by selecting the parameter and change the label to height. Right.
When you go to front, it has height already in there. Or you have height there. Yeah.
I don't think it oh, here's another one here. Okay. Yeah, height is already there. Thanks for pointing that out. I was looking at the left and it didn't have. Go to the front one and remove it. We're not going to use it. So just delete it. Because this type of template, it's good. Like if you're creating like a equipment, a solid equipment, but we're going to use the template just to create a door. And the thickness of the door is going to be 1 inch, and that thickness is not going to be parametric. So remove it, and so that I can also schedule the sizes appropriately. I just swap the height to here. And you can also stretch the reference points a little bit so that they intersect. So what else I need to do? Okay, so another thing I'm going to do is to make these the insertion point. Make this the insertion point. And why is that? Because when I bring the door into the assemble, I want this point to snap to the center of the cabinet, right? And then I'm going to mirror it using that line, and that's going to create the opposite, the other one. And then I'm going to have, yeah, it's going to be like this, right? And so to change insertion points, I show you in the first exercise that you disable the origin of the vertical grid, the center one, disable it. Then I'm going to select this left one, and I'm going to define the new origin. So now the origin is going to be based on this element here. The other thing I'm going to do is notice how, yeah, notice how some reference planes are locked, are pinned, and what that means is that they are connected to the ground. They're not, the parameters are not going to move them, and that's fine. This is the center of the door. This is the bottom of the door. This is the height of the door. All right, so in the sequence of commands, a lot of things were predefined for me. When I open the casework category, there are already reference planes, there are dimensions, and there are parameters. So all this slide of instructions is already done for us. But again, I need now to define the thickness of the frame door. and the size of the glazing. So what I'm going to do is add additional reference planes that are going to represent the boundaries of the frame. And those are going to be 4 inches inset from the exterior boundary. So the way to do that, you can just create a reference plane, not line, reference plane. And the easiest way to do this is using the pick line tool with an offset of 4 inches. So in the offset, make sure you type 0.4, or if you want to add characters, just type 4 inches. And again, I'm using the pick line tool. I create reference plane. And then you're going to create a reference plane towards the inset. And this is a little subtle because if you move the cursor, if you approach the reference plane from the outside, it's going to make the offset in that side. So you want to make sure you inset, that the offset are inset. And I'm going to do this 4 times. And all I'm doing is representing the door frame. I did it 4 times around the frame, 4 inches inset, and the distance is equal around. I'm going to move the width away a little bit so that I clear this. And that is the framework of my door. Now, don't do this, but when I flex this family, say I move this to be 2 feet. Notice how the frame doesn't react to the change. The frame of the door frame doesn't react to the changes in the parameter values. And so I'm going to undo this, and to make sure that the 4-inch offset for the door frame is consistent for every family type, I'm going to create dimensional constraints. And the process is adding a dimension, give it and lock it. When you lock a dimension, then you're making sure that no matter what the width or the height is, the 4 inches are going to get retained. So we're going to do this around every edge. So you go into the dimension tool, align dimension, and we're going to do this 4 times. Let's start from the top, place this dimension and lock it, place this other dimension and lock it, and we're going to do this on the left side. Don't forget to lock it. Place it and lock it. If you forget to click the lock and suddenly it disappears, you can just go back, select the dimension, and relock it. With these 4 dimensional constraints, let's flex it again. If the door width changes to 2, then the frame moves with it. 3, it moves with it. Let's change the height to 4, then it moves with it as well. Okay, any question? Is it working? All right. So to recap what we did, we created this as the insertion origin. We swap some of the parameters to make it align with the actual door nomenclature, height and width. We deleted the height in the elevation one. And let's think also where the pool is going to be placed. And so the pool, I'm actually going to place it right here. Right? And so the pool needs to be at the midpoint or at the center point of the of these 2 reference planes. And so what I need to do is to add a new reference plane. And to make sure that this reference plane is equidistant to the existing frame. And so I'm going to create a dimension, apply the EQ, so that it remains equal. And then that reference plane is going to move with changes in the frame. And then the other thing I'm going to do is, remember the insertion point of the pool is right at the center. And so I need also add another reference plane that's horizontal and that's equidistant from the with the door frame, so that no matter what is the size of the door, the pool is always going to be left center. Does that make sense? All right, let's do that. Let's start with the vertical one. So again, RP, or you can just go create reference plane, and let's place a new reference plane on the left frame. And then let's add an equal constraint. We're going to use a dimension, align dimension, and create a string dimension, 3 clicks. The last click is a placement click. Escape. If the numbers are getting on top of each other, it's just a matter of changing the scale. I'm going to change the scale to 1.5 = 1. And notice how this is a dimensional constraint, but I'm just going to make it equal here. And so any changes in the door size is going to drag the location of the pool. So let's flex it. Flex this to be 2 feet, apply, and you see how it drags it. Flex the height to 3 feet, and you see how it remains in place. Now, this is going to, this reference plane that I have selected here, again, repeating, make sure that you have a string dimension, that you enable the equality constraint. May also sure that these 4 dimensions around are locked constraints. Whenever you select it, you see these, there's a locked. These reference plane I have selected indicate is going to anchor the pool on the left side of the frame in the X direction. And now I need a way to lock it in the Y direction. So again, I'm going to create a reference plane at the center of the door. This reference plane needs to be equally placed between the top frame and the bottom frame. So I'm going to add a dimensional constraint, add a dimension, and a string dimension, 3 dots, three clicks. First click, second click, third click, and the last click is a placement click. Don't lock it. If you lock it, then the family is not gonna be able to flex. It's going to be connected to that specific value. What we want to enable is the equality constraint. And now let's see how the family behaves. We're going to flex it. Open the family type. Let's change the height to 4 feet. And look at how the center always remains center. We'll change the width to 3. And we're adding smart values to the families. All right, so looking at the list of steps, we are done with number 5, which is flex the family. We created reference planes, we added dimensions, we created parameters. The parameters were already there. All we did is reassign them, and then we flex the family. Then the next steps is to add the, I don't think we're going to add symbolic. Oh yeah, we're going to add symbolic line work. What do you think is a symbolic line work that doors have? Any taker?
Shelves.
That's yes. The lift direction. that's not a three-dimensional object, but it's something that we typically represent in doors. So if the pool is going to be here, correct me if I'm wrong, it's been a while. I think the leaf is represented like this. Is that right?
Opposite way.
It's the opposite. Okay. I always get that wrong. Okay, so is that is the direction. So this is the leaf, and those are going to be the symbolic lines. And the symbolic lines are only going to be visible in projection views. That means in true elevations. When you switch to a 3D view, these lines are not going to appear. Okay, so symbolic lines. Again, if we snap to the intersection of the grids, that's going to automatically lock symbolic line endpoints. So again, this is going to be my first point, my second point, and this is going to be my third point. So you go to the Annotate tab and hit Symbolic Lines. And symbolic lines comes in subcategories. Subcategories are different line styles. And subcategories are also visible in the host project as invisibility graphics. So when you type VG and you open the subcategories of the project, you will be able to see if any of the geometry in the family belongs to a subcategory. So in the case of the leaves, I'm going to pick elevation swing in projection, right? This is in projection. Elevation swing in projection. And again, I'm going to snap to the intersection. And then I'm going to snap again to this intersection. And then I'm going to snap again to that intersection. And then hit escape. Let's see if this flexes. This needs to flex in X and Y. So family types, and there's a lot of flexing in the process, unfortunately, because we're basically designing a smart object, and we need to validate all the steps in the way. So I'm going to change this to 3 feet. Yes. And the height, let's change it to 4 feet. And notice how the symbolic lines are responding to changes in the parameter values. That makes sense? Okay, so this symbolic line, it's only going to be visible in projection, which is nice. And that takes care of step number 6, which is create symbolic line. All right, the framework is ready. Now I need to add the meat, the muscles to the family. Add the solids, and I'm going to do 2 things. I'm going to create the frame first, which is this thing. The frame is going to be 1 extrusion, 1 inch in thickness. And then I'm also going to add the glass. And the glass is going to be 1/4 of an inch, and it's going to be 1/4 of an inch offset from the reference plane. So let's start with the outer material. All we need to do is create extrusion. An extrusion is a profile extruded along a direction perpendicular to the view. Let me show you. This is what extrusion look like. You create a profile using sketch lines, and these sketch lines are hosted in the work plane. And then they are extruded in a direction that is perpendicular to the profile. So you go to the extrusion, you are in the sketch mode. All you can do is create a sketch line. The easy way to do this is using rectangles. So switch to the rectangle tool in the draw tools. And again, I'm going to snap to the intersection. And notice how this is telling me endpoints. I want to avoid snapping to solid geometry, and to force to snap to intersections, type on the fly SI, snap intersection. A snap intersection is going to force to find reference plane. Because this is going to create the automatic alignments. And then I'm going to snap again to the opposite side. And that's the outer boundary of the door. You don't need to lock it. You don't need to lock it as long as you snap to the reference plane. It generates this automatic sketch relationship. And then the inner boundary of the frame. So I'm going to start from the intersection of this, and then I'm going to snap to the intersection of the opposite in the diagonal. Escape. And then let's look at the dimensional extrusions. So notice how this says extrusion start and extrusion end. Start is 0 dimension from the work plane. The work plane is at the bottom. And so the thickness of this frame is going to be 1 inch. So the extrusion end should be 1 inch instead of 1 foot. And notice how it automatically tells you what is the work plane of this sketch line. Apply. And then the other thing I'm going to do is to define the frame material. This could be wood, this could be steel, this could be you name it. But I'm not going to define it in the family environment. I'm going to define it in the host. So again, I'm going to do the same what I did with the pool. Activate the family associate parameter and create a new parameter. I'm going to call this door material. And it's a type parameter, and notice automatically place the rest of the information. Hit OK. Notice how this grayed out, and the door parameter is now a type parameter. All right, so it's 1 inch. I define a material, then I hit the green checkbox. And in 3D, this is what's happening. I have the exterior frame of the door that changes to changes in the parameters. I'm flexing it in 3D. You don't have to do it. I'm going to do. All right, now let's do the glazing. The glazing is going to be 1/4 of an inch, and it's going to be 1/4 offset from the reference plane. And it's going to have a glass material. So same thing, you go to the Create tab, and we're going to do extrusions. Again, the easy way to do this using rectangles. And to force Revit to snap to intersections, we do snap intersections. So you go SI, just type on the fly SI, and that's going to snap to the intersection of reference plane. Always snap to the framework. Don't snap to the solids. And then in the diagonal opposite end, SI. And now let's look at the dimensional extrusions sizes. So the extrusion is going to start 1/4 of an inch from the ground. So I'm just going to say 1/4 of an inch at the start. And it's going to end, I need to add the 1/4 of an inch. There you go. And then it's 1/4 of an inch. So 1/4 plus 1/4 is going to be 1/2. So it'll be 1/2 an inch is going to be the extrusion end. You can erase, if you want to do the math and make it right at the center, you can do that as well. I'm just going to leave it at 1/4 and 1/2 an inch. And then the other thing I'm going to do, this is always going to be, I could decide, I could allow the user to pick the type of glazing. I mean, sometimes could be, could be a fire type of glazing. And so instead of defining it into the family, I'm going to add, and I'm going to associate the family material of the glazing to a new parameter called door_glazing. So same process, hit the new parameter icon and create a parameter called door_glazing. It's going to be a type parameter. Then hit OK. Notice how parameter, and the value becomes grayed out because the value is driven now by a type parameter connected to the library of materials. And then hit the green checkbox. And again, if I switch this to 3D, this is the door. I could bake the glass material right now. So I could just go into the family types, hit the door glazing. And when you, if you see those 3 little dots next to the, in the cell, it's gonna open the family materials. You just select glass, hit apply, hit OK. And that's the door with the inserted glass that is also flexible. So to test it, you don't have to, but I'm sure it's working on your end. This is a 3 feet, 2 feet, and then the height 4 feet, 2 feet. I'm going to leave the height in 3 and the width in 1. No, that's too narrow. Let's do it in 2. All right, so this is I have the frame ready. I have the door finished. Now what I'm going to do is to bring the pool. And the pool is going to be aligned with this work plane in the X direction, and it's going to be locked to this work plane in the Y direction. All right, so let's bring the pool. But before I do that, before I bring the pool, let's create a subcategory for the pools. Because when you're working in 3D, you may decide that you don't want to display the pools, that's maybe not in contract. Or that you want to assign a different materials to the pool based on subcategories. And so I'm going to create a custom subcategory for pools, bring the pool, and then I'm going to finish. And I know I'm a little over on the time. So in the visibility graphic of the family, just type VG. These are the limited, these are the 2 subcategories used by the family. But you can create a new subcategory by adding, you go here, click Object Styles. And in the Object Styles button, you can add a new subcategory. And I'm going to add the subcategory of pool. And if you want to be very granular, you can add like subcategories of glazing or door frames. And these subcategories are going to travel into the project. And in the Revit project, you have the ability to switch this as checkboxes in visibility graphics. So don't go overboard. I mean, the decision of adding subcategories is based on what are the characteristics of the component you want to control in the project. So pools, I'm creating a subcategory of the casework. You will be able to switch all the pools in the project using this category. I'm going to apply this, hit OK, and that subcategory is ready. So now I'm going to bring the component. So go to the Insert panel and then load into the project or load family, and go to the place where the pool is stored. If you didn't finish the pool, just grab it from the Google Drive. I have it on my C drive. And I'm going to go to the window, Oxman Fall. Here's the pool I just created, hit open. And that family is going to be available to you under the project browser, under the generic models. And you see the 3 types that I created available to you. I'm going to pick the 6 inches and then just drag it and drop it. I'm going to snap it to the intersection of these of these two grid lines. And now, do you know why this looks like a line? Any taker? And it doesn't look like the full
Because you're set to course right now.
yes, correct. This is to course, but when I switch to
2
fine,
points.
yes, you see to fine, then you see the whole thing. That was the intelligence that I embedded to the object. Excellent. So let's see it in 3D. That doesn't look the right location. It looks like it's been placed in the low in the at the host plane. So let's fix that in an elevation. So I'm going to switch to the left, no, to the front. Oh, I need to switch this to fine in order to see it. Here it is. So I'm going to select it, and I'm going to do something called align. And when I align something, I lock it. So I'm going to align to the vertical location of the pool. So you've used this before. You hit the align tool, align where to the face of the solid, align what. You hit tab to select the lower face of the pool, and then you lock it. You have to lock it so that it doesn't move in the Z direction. Let's go back to the floor plan, and let's see if the pool location react to changes in the parameter values. So I'm going to change the width to 1, and notice it doesn't lock it. And so I can fix this using, again, the alignment. And I have to use it when you bring components and you want to lock them to the host. We align them and lock it. So in the X direction, again, change the value to something else. I choose 1 feet here. And then on the modify, I hit align to this reference plane, the center of the reference plane. This highlight in the family represents the center reference plane in that family. And when you align it, make sure that you lock it. So in the X direction, I believe this is locked. I'm going to flex it and notice how it moves with the component. Let's see if it moves and changes in the height. Changes to 4. Notice how it doesn't flexes with the height, but I have to do exactly the same procedure. To align it with the horizontal work plane, go to the modify tab, align where, align to the center line, to the center reference plane, the center of the pool. And you just move over, it's gonna pre-highlight for you. This is the center of, this is the reference plane nested inside the family, and then lock it. And then I'm just gonna flex it in the height, 3, apply, and now it's working. Width 2, and height 4. Beautiful. So I have now my fully parametric door working as I needed to. It has the appropriate parameter. I have the door glazing material, the door material, the X, Y, and Z. And before I save it, a very important concept, it's enabling the family to be hosted by a work plane. So this door is going to be brought into another family. But if I don't do anything, if I just leave it like that, the door is going to come associated with it's going to come flat at the floor, right? And by default, the casework or the casework template it's built to bring families, to align the reference plane of the two families. And so to override that behavior, I have to go into the family category parameters. Is the button that is above the family types. And enable this parameter that says work plane based. And what this is going to do, when you load this door into the host, which is the cabinet, you're going to have to pick what work plane the family is going to get aligned. So otherwise, it's just going to come flat to the floor. So these enable the family to be work plane based. And the other thing I'm going to disable, it's clear the always vertical. Always vertical also constrain the geometry to come in a specified direction. Here's another one that I use at your discretion. This is called a share parameter. Again, this dialog box, it's available here in this button. This share will expose the component families in the project. So if you don't want the door to be a family that you can access into the project, leave this unchecked. But if you check this, when this family is loaded into the project, the door is going to appear in the project browser as a family that you can drag and drop. So the components can be shared and made visible in the project, or you can disable that behavior. In this dialog box, just make sure that the work plane base is enabled, clear the rest. And this is how you change one family category from one type to another one. If you scroll down, this allow you to change the template from casework to another category, FYI. So hit OK here, and I'm done. So hit save. And again, I'm going to save this in my C drive under my Oxman Hill, and I'm going to call this door panel. And then save it. And then at the start of next class, we're going to assemble all the pieces together. We're going to create a cabinet that is wall-based. We're going to create the body of the casework. We're going to bring the shelf. We're going to bring the door. And then we're going to create an array of shelves and mirror the door, connect family parameters with host values, because the size of this door is going to be driven by the size of the host. And we're going to finish the exercise then. So any question? Cool. And I know you had troubles. So we are at the end of the class, but I'm going to stay here to give you some troubleshooting. Any other question? Yeah.
Yeah, because I missed last class. Are all your classes going to be on recorded, and we could go back?
Yes. Just go to the YouTube channel link that I share on the invite.
Okay.
You can watch it again.
Okay,
The
great.
class from yesterday, I repeated all the steps, by the way. So
Okay. Yeah, no, just ongoing. It's always great to be able to go back. So these are all recorded. Great.
yes.
I have a question.
Mm-hmm.
Would we always build a family from the reference level, or like could you also build it, like could we have built this vertically instead of flat, in floor plan view, or is there a reason why we do that?
Yeah, so notice how this casework family has this big reference level. These when you create a family that is work plane based, what is basically Revit doing is identifying where is this work plane and using this work plane as a placement alignment in the host. So when you say work plane base, you're actually using this reference plane as the placement in the host. And so the reason I did it flat is because in my mind, I wanted to use these reference as the placement. If you do it vertical, you could have done it as well, but then your placement was going to be this one, right?
Mhm.
And nothing wrong with this, except that yeah, you just need to, nothing wrong with that at all. You could have buildings horizontally, but in elevation, you need to create additional reference planes, and because the template already comes with a width and a height, and is already prepared, the box is prepared for you. I thought it was better to use the plan view than it's an elevation, but technically you can do it also in elevation. It's just going to be additional reference planes that you need to build in an elevation view.
Gotcha. So when we like put the cabinet together, there's a way to like orient that reference plane or that work plane to the cabinet.
Yeah, these work plane, it's going to align to whatever work plane in the host you decide. This could be the face of the front cabinet, the bottom cabinet, the top. I mean, you're going to pick the face that this work plane align to.
Gotcha. Thanks.
Yeah. All right. Any other question? I'm going to stop this live stream, and I'm going to